Finding the area between two curves is a pretty common application of integrals that you'll run into as you take integral calculus. But it can also be one of the more challenging uses of integrals that you're going to run into. So in this video, I wanted to show you a portion of my live stream that I did recently, which I'm doing every Monday night at 5 o'clock Pacific time, where I talked about how to find the area between a few different curves. Specifically in this video, I'm going to be showing you how to find the area between y equals natural log of x times y equals 4, x equals 1, and x equals 3. So those are going to be the four kind of curves that we're going to be using to find the area between those four curves. However, this is just an example. As I go through this example, I'm going to talk about the things that you should be thinking about and that you can apply to basically any problem to find the area between curves, so that you can apply this same method on your own for any other example you'll run into, which I think you should find pretty helpful. So be sure to stick around to the end of the video. And without further ado, let's go ahead and jump into the example. Sketch the region enclosed by the curves, then find the area of the region. Same kind of thing as the last example we just went through. First thing we always want to do with these problems, whenever we're finding the area between two curves, we always want to start by sketching them. That's really just going to help you figure out which direction you want to integrate with respect to. Y equals the natural log of x was right. It does look like this. However, what I was wrong about, or what I did not consider carefully enough, let's think about just kind of in this area from like x equals 0 to x equals 3, what this function really looks like. So to do that, let's just kind of plug in a few x values and see what we get. So if x is 1, we get y equals 4. So this really should be basically like right here. This point, or this function, is going to go through this point. At x equals 2, we get 4 over 2, which is 2. So at x equals 2, we get basically like here. And then I should probably be a little more careful about my graph of natural log of x now that I'm labeling my axes here. Let me redo that. It is going to go through this point here, 1, 0. And then natural log of x, if we were to plug in, if we plug in e, which is like 2.7, so right here, we would get 1. So actually it's a little bit sharper of a curve here. We're going to come like this. That's what natural log of x is going to look like. So then for 4 over x, we're going to get at x equals 2, we have this point here. At x equals 3, we have 4/3. So at 3, we're actually a little bit up here-ish. So really, this function 4 over x is going to look like this. So the reason why this is very important is because now if we think about the edges here, x equals 1 and x equals 3, we would get a vertical line at x equals 1 and a vertical line at x equals 3. Well, notice how this is a bit different from what I was drawing before here. Now we have this region here where all the way through the whole region, this vertical line here is just our left edge, and this vertical line here is our right edge. 4 over x is the top of this region all the way through, from left edge to right edge, and natural log of x is the bottom edge of this region all the way through, from left edge to right edge. So we actually have something easier than what I initially drew. So that's, a good lesson for you. Be careful about your sketching of your curve, because it is really important to kind of figure out how these two curves are related to each other. And how we could have probably avoided the mistake I made before was to just plug in some points, right? It really can be that simple sometimes. Just plug in some points that is, around the region. So this, x equals 1 and x equals 3 tells us that between x equals 1 and x equals 3 is probably what we care about. Just plugging in some x values around that area could have kind of helped us to avoid that problem. So now that we've gotten that, it can be helpful too, as you're learning this stuff, to use a calculator or Wolfram Alpha or something like that to graph your functions so that you can see what they look like and use that in your sketches. But if you're on a test or something, obviously that may not be an option. I would just recommend plugging in points within the area that you're concerned with. All right, so now that we've got that, we know, again, going back to the formula on my study guide, we're going to do the integral of our top function minus our bottom function. right? Well, like we can see here, like I just pointed out here, our top function is 4 over x all the way through, and our bottom function is ln of x all the way through. So that's really going to be actually pretty straightforward. We're going to take the integral of 4 over x minus the integral of natural log of x with respect to x. And then we know that our left edge is just x equals 1, and our right edge is x equals 3. So that's going to be the bounds of our integral from 1 to 3. Okay, so now we can integrate this. The integral of 1 over x is going to be, let's see here, is going to be natural log of x. So the integral of 4 over x is 4 times natural log of x. And then the integral of natural log of x is actually fairly complicated to find. Well, not really, actually. I shouldn't say that. It would take a handful of steps. I'm not going to go through the whole process of finding that. If you wanted to find that by yourself, you could use integration by parts, actually, to find the integral of ln of x. I'm not going to go through all those steps. I believe I've made a video on that if you want to check that out. But if not, just to give you a hint, integration by parts would be the way to do that. But the integral of natural log of x is x times natural log of x minus x. So we're going to have x times natural log of x minus x. So keep in mind, this right here is the integral of ln x. Since we had minus ln x here, we need to say minus all this stuff in parentheses. So now that we've integrated that, we can evaluate that from 1 to 3. Before evaluating that, though, I'm going to go ahead and simplify this by distributing our negative sign. So we're going to get 4 ln of x minus x ln of x plus x from 1 to 3. So now to evaluate this from 1 to 3, we would just plug in 3. So we would get 4 ln of 3 minus 3 ln of 3 plus 3. So that is plugging in our upper bound, and then we do minus plugging in our lower bound. So 4 ln of 1 minus 1 ln of 1 plus 1. And make sure to put all this in parentheses so that this minus sign right here is going to distribute through there. So now we can simplify this. 4 ln of 3 minus 3 ln of 3 is just 1 ln of 3 plus 3. Ln of 1 is 0, so both these terms right here are going to go away. And then this negative sign will distribute to this plus 1, giving us minus 1. So we get ln of 3 plus 3 minus 1 is plus 2. And that is going to be the area between these two curves that we had here to start. Well, I hope you found this video helpful and you feel a lot more comfortable with this topic now. Like I said, this was one of the topics covered on my integral calculus cheat sheet or my calculus 2 study guide. If you want to check that out, there is a link down in the description below where you can learn more about that and go get your copy today. And if you found this video helpful, please do me a huge favor and hit that like button down below. It really helps support my channel so I can keep making more videos like this. And if you want to keep learning about integrals, I've made a ton of other videos on the topic. Just go click on one of those over there and I'll see you next time.